All right. Hi, good afternoon. Welcome to join us. This is OpenStack Storlets session for project update. So I'm glad to present project overview and the current status for you here. And I'm Kota Tsuzaki, working for NTT, and have been running a PTL for Storlets for 3 cycles. Let's get started. First, I'd like to describe what is Storlets here. Storlets is the plugin of the OpenStack object storage suite. And the project mission is to provide efficient application execution environment for object storage users. And this project provides the functionality for users to be able to run their application code inside of the object storage system easily. And it's triggered. The application code can be triggered just by the Swift API. So like this, basically that depends on the Swift object storage, and the storage is a gear for your applications. So for detail, let me dive into storage a little bit more in the next 2 slides. So before introducing how the storage works inside the object storage, I would like to describe what's object storage. OpenStack Swift is an object storage system to abstract your data storage. As you can see, Swift can be stored any computer data, like PDF, documents, movies, and audio, and like images. And the left side, you can see prepare a bunch of servers that equips the hard drives. So Swift deals with which data is being stored in which storage hard drives. That means what user should do for storing is just preparing your data and making a request. Hey, the Swift, please save my data at this name. Then for retrieving the objects, just calling the Swift API as well as when you store your data. And the basic usage of the object storage is simply storing data in a single namespace and then get the data as well. So this is the object storage. Storage follows the simplicity of the Swift object storage system. Storage API is an extension of the Swift API. So user can invoke storage application when you call a Swift API. And the user application code is stored as the Swift object. So for the preparation, what the user should do is just uploading your code as well as other kind of Swift objects. Then define the path, your application code path. Define your application path in the storage API when calling your Swift API call. So when the API called, storage automatically create the application sandbox via Docker that is containerized in the Swift hard drives, then attach the data, the Swift data, to the container as the stream input. So the benefit of storage is that users don't have to download the raw data if you want to process the data. At that case, what you do is just uploading your code to Swift and then calling storage API. So the mechanism is really useful to process your data in case of the kind of encoding movies, creating thumbnail, and so on. So this is what storage supporting. So this is the a high-level overview of the what's Swift and the storage. And then let's move on to the current community status. The storage founded the Mitaka version of the OpenStack that is in 2016. And this Stein release is the 3rd release of the third leaf after the changing the release model to the milestone cycle release model. And then, so, and I think the good thing is that the contributors are being from various companies. So basically, the storage at the first, really beginning early times of the storage is just contributed by the IBM and NTT. That is basically the first founders of the storage. But as you can see, this is the current, the recent Stein's review stats. You can see various companies in the list. So that's really good movement and the community being healthy, I think. And one thing I would like to introduce is Takashi is now, so we have the one core reviewer for, from working for Red Hat. So we have new contributors at the Red Hat currently. That's really good thing, I think. And also, finally, I met the awesome thing. This is what I've heard in the summit, in this summit personally. So that is free to deploy the storage in production for their customer, so that we can call the storage project as production ready for now. So this is really great thing, great news, obviously, I think. Yeah. So, all right. And then from here, let me introduce the new feature of the Stein. So this is, sorry, this is only one thing I can tell for the new features, but I think it's really important because we will retire the Python 2. So the good thing is that we are now supporting Python 3 environment for user code execution. So in the older storage, we have a couple of languages to support for user language, Java and Python. But that Python is just Python 2.7. So in the older storage, users have to write their code in Python 2.7. So from the Stein, release 3.0.0, user can create your code, user codes via Python 3 formats. So that means you can, and also we are still supporting 2.7. So users can choose their Python runtime version, 2.7 or 3.6. So users don't have to mind the code compatibility between the Python runtime version when considering the make storage application written in Python. However, in the train, we still have some homework for Python 3. As you might know, the Swift storage depends on is still going to the work Python 3 compatibility at the server layer. So and also storage needs to integrate Python 3 for the server code. So, and as you know, Python 2.7 will be dead in the end of this year. So we have to migrate server code to Python 3. Basically, we have already Python 3 unit tests. So all unit tests passed in the Python 3 environment. But we don't still not yet have the Python 3 functional tests. So we should complete the to make the Python 3 functional tests in the gate, so running Python 3 script and running Python 3 storlets, and then call the storlets functional tests via Py3 in the gate we should do. And one more thing I'd like to expect to happen in the training cycle is supporting other container runtime rather than Docker, especially for security consideration. Some technologies like Kata container would be nice to have, I think. Yeah. This is not yet this is not yet done currently. But anyway, we need your help, everything. So even the contributors are being diverse, the development is not so fast currently. So contributing to the project is really helpful for us. So please tell us anything for your contribution. And also, like Fujitsu, telling your use case and the requests to the community. So that what you want, telling what you want for production is absolutely great, great contribution for the community. So I'd like to encourage the community to work to progress more in this training cycle. That's all. Sorry, that's really fast. So we have I think the 9 minutes. So if you have the questions, please. Yes. Uh-huh.
Object servers or proxy or separate machines.
Uh-huh.
Where does it execute? Where does it run?
Basically, the Docker container, basically storage can be invoked at the proxy, both proxy and object server. So basically the point is users can choose where you want to invoke the application. But in default, at the proxy server, when user store the object, and then at the get time, the object is in default for the running execution environment.
Suppose, like, do you want to manipulate the object before you store it, or send it out to the proxy or the other? That's probably part of it too. Like, where the container would run, right? Are you running the storlet on the data after it's been spread out, or before?
Yeah, to reduce the network transfer as possible.
Is there some repository with good storlet example code to check out and test? Example, is that demo code?
Yes, you can see the demo code. All right.
Try to see this in action.
All right. Storlets did have. So storlets have some various example codes. I think the storlets. No. I think the storlets example. Oh, all right. Yeah, this is a storage repository in the GitHub, and we have the samples and the Java code or Python code. Then some code and here. Sorry, that is not mirroring. Okay, I can see that. Oh, okay, simple. Simple.py. Like here. So, okay. We have to plus. Okay, this is the Storlets framework. So the user just defined this class, sort of this class, and that is simply Storlets class. And the Storlets class should implement this function call, and then you can so in this method, you can write down your code, what you want around here. And basically, the input stream for the data is incoming at the in files. This is args. And then you can read any data, like we around okay, here read, yes, in files, and read that, and then the out file is just a file-like object for the output stream for the data object at the put time and the get time for the response body. Yeah, this is basic framework of the Storlets. And you can see also some Swift metadata likely here. Anything else? Thank you.